Welcome to another class. I'm Dr. B, your chemistry teacher, and today we are going to continue from our previous class, and that is unsaturated hydrocarbons. Today we are going to be looking at the unsaturated hydrocarbons. We had already in our previous class discussed saturated hydrocarbons, where we told us that saturated hydrocarbons are well identified by the presence of single bonds. And now today, talking about the unsaturated hydrocarbons, it is simply, of course we have already mentioned that hydrocarbons are simply molecules of compounds, of elements that contains only hydrogen and carbon as their major constituents. Now, looking at the unsaturated hydrocarbons, it's quite interesting to know that they are being differentiated from the from the saturated hydrocarbons due to the presence of single double bonds or even single triple bonds in their structure. Okay, so if you want to say this is an unsaturated hydrocarbon, you will be able to identify it by seeing a compound that possesses double bonds or triple bonds. And this is quite different from the saturated hydrocarbons where those compounds possess only single bonds. So, for example, alkenes, they possess double bonds, and for alkynes, they possess what? They possess triple bonds. And aromatic hydrocarbons possess also some level of double bonds. So, for every unsaturated hydrocarbon, there exists single double bonds or single triple bonds, or even more triple bonds or single bonds in the structure of the compound. You must understand that. That is what makes it different from saturated hydrocarbons. Now, do you know that because of the presence of these very double bonds and triple bonds in unsaturated hydrocarbons, they are deficient of hydrogen atom, unlike in the saturated hydrocarbons. So, because they are deficient of hydrogen atoms, they do not maximize the number of hydrogen atoms. Remember that in the saturated hydrocarbon, we had said that saturated hydrocarbons have a maximum, they maximize their number of hydrogen atoms. The reason why they approach octets by having their carbon atoms doing what? Carbon atoms attached to at least 4 hydrogen atoms. So they maximize the number of hydrogen atoms. But it's not like that with the unsaturated hydrocarbons. They do not maximize their hydrogen atoms because they are hydrogen deficient. I want us to also understand the fact that being unsaturated hydrocarbons, they also possess a tendency of some similar shapes. For example, alkenes as unsaturated hydrocarbons are usually identified with a shape like the trigonal planar. So wherever you see alkenes, they possess a shape, the trigonal planar shapes. And it will also interest you to know that these very unsaturated hydrocarbons, apart from the shapes which they possess as trigonal planar, they also have bond angles of 120. So alkenes has a bond angle of about 120 degrees, and then alkynes have a bond angle of 180 degrees, and these have about 120 degrees. So you see that the bond angles of unsaturated hydrocarbons stand at 120 for alkenes, alkynes is 180, and 120 degrees again for aromatic hydrocarbons. And it will also interest you to know that unsaturated hydrocarbons, especially the alkenes and alkynes, have low boiling and melting points. So to understand what unsaturated carbons are, you must convert every of their statements to bullet points depicting properties. And if you do that, it will be very easy for you to have it in your head what they are all about. I have mentioned here that both alkenes and alkynes as unsaturated carbons possess low melting points and boiling points, even though alkynes have a little bit of a higher melting point than alkenes. And I also mentioned that they have bond angles of 120, 180, and 120. I also mentioned that they possess or they carry what? A trigonal planar shape. I also mentioned here that they have hydrogen atom deficiency, and because of that, they do not maximize their number of hydrogen atoms like the saturated hydrocarbons. Do you also know that we have mentioned here that they possess double bonds and triple bonds? So you must convert their statements into bullet points to depict properties before you can be able to understand or carry them in your head. Now, let us quickly look at this diagram that we've put on the board here that summarize what unsaturated hydrocarbons are. Unsaturated hydrocarbons are divided into three: alkenes, alkynes, and aromatic hydrocarbons. And they are identified, their names are identified by their suffixes. So for alkene, they are always identified with ENE. And for alkynes, they are identified with YNE. Okay, and the aromatic hydrocarbons are always identified with ENE like alkenes. So we have three types of unsaturated hydrocarbons. We have the alkenes, we have the alkynes, we also have the aromatic hydrocarbons. And I said the compounds are always identified with the suffix, that is, their names will always end with ENE for alkenes, and then YNE for alkynes, and then the aromatic hydrocarbons are identified with the ENE just like the alkenes. Now, we had also mentioned that alkenes are always identified with double bonds. When I had started earlier, I had mentioned that to identify unsaturated hydrocarbons, you must know that the compound possesses single double bonds, carbon-carbon double bonds, or single carbon-carbon triple bonds. Now, the carbon-carbon double bond is always identified with the alkenes, which is a type of unsaturated hydrocarbon. And then the carbon-carbon triple bond is always identified with the alkynes, which is the second type of unsaturated hydrocarbon. And then the aromatic ring structure is always identified with aromatic hydrocarbons. They are aromatic because they are stable compounds. So aromatic ring structure is always identified with this. Remember that aromatic ring structure is different from cyclic structures. Remember we said in saturated hydrocarbons that we have cyclic structure like the cycloalkanes and the alkanes. So cycloalkanes are different, they are not aromatic. So they are not aromatic ring structures, they are just cyclic structures. So for unsaturated hydrocarbons, for aromatic hydrocarbons, they possess aromatic ring structure, which is something like this. And then you also understand that in identifying or in naming these very alkenes, alkynes, and aromatic hydrocarbons, you must see them in this form, where the arrows that are written here are simply the methane group or the methyl groups. So you have this as the formula in terms of the structure, identifiable structure for alkenes, identifiable structure for what alkynes, where of course these are what the methyl groups or the arrow groups. And then down here is an example for each case. So you have a theme. A theme is C2H4, and this is how it is written, with double bond at their carbon ends, with 4 hydrogen atoms, deficient of what? 2 hydrogen atoms. Now, if you see here, you see that for alkynes, this is ethyne or acetylene. Either you call this ethyne or you call it acetylene. Either you call this ethane or you call it ethylene. The same thing. So this is an example of an alkyne, which is what? An ethyne, or you call it what? Acetylene, C2H2, deficient of about about 4 carbon atoms, or about 3 carbon atoms as the case may be. This division about 2 and about 3 of them. Okay, so if you take a look at this is an example of an aromatic hydrocarbon with aromatic ring structure, and benzene is always a good example of what? Of an aromatic compound, of an aromatic hydrocarbon. So you can see that the whole of this diagram explains what unsaturated hydrocarbons are. And this is CnH2n, which is the identifiable formula for you to identify alkenes, while CnH2n-2 is the identifiable formula for you to use and identify what alkenes are. Do not forget that when we did saturated hydrocarbons, we had written something like CnH2n plus 2, and this was for the saturated hydrocarbons. To be able to name these various saturated hydrocarbons, you must use this formula where n is the number of atoms. So, but for the alkenes, there is no plus 2, and for the alkynes, there is minus 2. This is telling you that there is deficiency in the number of hydrogen atoms for the unsaturated hydrocarbons. I'm sure you have been able to capture something interesting describing what the unsaturated hydrocarbons. But to end this class, let us look at the basic reactions of unsaturated hydrocarbons. Let us look at the basic reactions of the unsaturated hydrocarbons. Now, do you know that unsaturated hydrocarbons carry out or get involved in 5 strategic reactions? And the first reaction is addition reaction. Addition reaction. And the second one is oxidation reaction. And the third one is hydrogenation. Hydrogenation. And the fourth one is combustion. And the fifth one is polymerization. These are the 5 basic reactions of unsaturated hydrocarbons. These are the basic, there are more, but these are the basic reactions of the unsaturated hydrocarbon. And the most important reaction is this, addition reaction. This is the reaction that differentiates unsaturated hydrocarbons from saturated hydrocarbons. Saturated hydrocarbons do not undergo addition reaction. They don't. It is only unsaturated hydrocarbons that are identified with addition reaction. So at any point in time, you carry out an addition reaction over any type of hydrocarbon, and notice that it gives you a basic product. It means it is actually an unsaturated hydrocarbon. Now you have the oxidation reaction. Okay, so it means that now for the addition reaction, it will interest you to know that unsaturated hydrocarbons will always react with alcohols, with halogens, other compounds. But basically, this addition reaction of these unsaturated hydrocarbons, it's always with alcohols, with halogens, and as the case may be. And usually, this reaction will always return unsaturated hydrocarbons from their double bonds or triple bonds down to their single bonds. And that means it will return them to saturated hydrocarbons. Okay, now hydrogenation means that in addition of hydrogen, you can possibly return also unsaturated hydrocarbons towards saturated hydrocarbons. Now, for example, you can have something like let's say you have CH2, okay, reacting with hydrogen. This is gas. They're all gases. So you can possibly have CH3 to CH3. Yeah. Now let me write it where it will be clearer for us. So you can possibly have an equation like CH2 gas reacting with hydrogen gas, and this will give you CH3 to CH3. You can see that this is a 10, this a 10, and this is a thin. Okay, so this can be written as this. Okay, so this can be written in this form. So this is a thin reacting with what? Hydrogen in hydrogenation, and then it gives you what? An ethane, which is what? An alkane. This an alkane. So it means that this can also be written as C. Okay, so all right. You see, so this can also be written like this. So this is single bond, and this is a double bond. Okay, so okay, sorry. Okay, so this is a double bond, and this is actually a single bond. So from here, through hydrogenation, you can have a saturated hydrocarbon, and they will have combustion. Combustion reactions with unsaturated hydrocarbon will always give you a product of carbon dioxide and water. Okay, so whenever you react an unsaturated carbon with through a process of combustion, we always expect to have CO2 gas and water. And then polymerization is another type of reaction that is being undergone by unsaturated hydrocarbons. I'm sure we've had much already today on unsaturated hydrocarbons. Do not forget to subscribe at my YouTube channel, okay, which is Dr. B Chemistry Classes, right? And then don't forget to leave your comments in form of question or otherwise. It will be attended to. Don't also forget to leave your comments in my Facebook page, Dr. B Chemistry Classes, and leave also your likes and share, and do not forget to follow. Until next time, it is a bye for now.